I'm having a campfire s'mores crisp bar. Hopefully for tonight, pages 277 and 291 only. So, our objective for today, I can add, subtract, multiply, and classify polynomials. I can add, subtract, multiply, and classify polynomials. What is our concept for today? Polynomials. So by now, since I did a review yesterday, we should know the definition of polynomials. Study never the definition, please. Monomials, sum or difference of monomials. I gave you guys examples, non-examples, and we said they're expressions only with various terms. Stop. All right, polynomials. We go with that, yeah? Yesterday, I also reminded you of the names of polynomials, also known as classification. And I said, if you need to brush up on these, the video is going to be up there with a table so you can study your names. Yes? Yes. All right, copy this one. Example Q. Classify the polynomial 3y minus 7x to the fourth y minus 8 plus 4x squared. Yes, please. I said copy that, please. Not the steps. Those I just put them there so that you guys can see the process. I'm going to show you the process. To classify a polynomial, we need to set it in standard form. That means from highest degree to lowest degree. How do we do that? Identify each degree of each term. Mr. Q, how do I know what the terms are? Well, by circling your terms. You start here. Every time you see a minus or a plus, you stop before that and circle that term by itself. There it is, 1. I start again. There's another negative there. That's 2 terms. There's a positive right there. That's 3 terms. Four terms. All right, here it goes. How many terms? 4. Now we can identify each degree for terms. Where do we look at? At the exponent of the variable. This one is an invisible 1, so this is degree of 1. This one is 4, but here's another 1, so that means 4 plus 1, this is 5. This one doesn't have a variable, this is 0. This is 2. So now we just move stuff around and rewrite it from greatest to least. So I start with negative x to the fourth y, and then from there I go to plus 4x squared. Then I go to plus 3y, and then lastly I do minus 8. Now it's in standard form. All right, now we can actually give it a name. What's the highest degree? Highest degree is 5. This is a quintic. And let's see how many parts. Is it 1 part? No, or else it would be a monomial. 2 parts? No, or else it would be a binomial. 3 parts? No, it will be a trinomial. Anything after that is a polynomial. And lastly, once you have it in standard form, look at the first term. The number multiplying the variable is known as the leading coefficient. So therefore, the leading coefficient is negative 7. All right? Yes? So, oh, the first name is always the degree, according to degree. And then the second name according to the term. Okay? All right, do one by yourself. Copy that one. Example, super key. See how you do. Copy that and go. Step 1, identify the terms. There's 3 terms. This one, first degree, third degree, second degree. Rearrange. 5a squared b minus 3a squared plus 9b. This is standard form. The highest degree is 3, so this is a cubic. 3 terms, so that is a trinomial, a cubic trinomial. What is my first term right here? So my leading coefficient is 5. Yes? All right. Move on. Example 1. Let's crank it up a notch. Add or subtract polynomials. Copy that, please. By the way, this should be a piece of cake. The only thing, we just added terms, but this is exactly what we've been doing on the warm-up. Yeah. Just copy it, and then I'm going to go through the process before you get started. All right. Here goes the process. Step 1. Set each polynomial in standard form. So now that we know how to do that, I'm going to go a bit faster. Which one goes first? 5a squared b, then minus 3a squared plus 9b plus 5, plus negative 2a squared b minus 7a squared plus 2b minus 1. Now that we have it in standard form and it's addition, we don't need to do anything with the parentheses. That's just to separate those polynomials. Now we can just start combining like terms. This is where you get your color pens ready. I start with this one. Is there another a squared b? Yes, right here. So the variables, they have to be the exact same variable with the exact same exponent. Are they the same? Yes, I'm going to write it so that I don't forget that they are the same, and I just focus on the coefficients. What is 5 minus 2? 3. There it is. Next, a squared. Is there another a squared? Yes, there it is. Since they're the same variable, I'm going to write that first, and I'm going to focus on the coefficient. What is negative 3 and negative 7? Negative 10. All right. Now I have that. I'm going to do the 9b. I'm going to do a triangle there and a triangle here. All right. Are they the same variable? Exactly the same? Yes. B. So I'm going to focus on the coefficients. What's 9 plus 2? That's 11. And lastly, focus on the constants. Here's positive 5 and minus 1. That's positive 4. And that's how you add polynomials. Look at it. Tell your neighbor what kind of polynomial this is, please. Yeah, it's cubic because the highest degree is 3, and more than 3 terms, it's a polynomial. Okay? Once again, yes. The numbers. Classification? We'll do that at the end. I'll bring up the table again. All right. Really quick. Note. Asterisk, heart, only combine if they have exactly the same variables and exponents. Both, if they have 2 variables, both variables have to be the same and the exact same exponents. Am I being clear on that? All right. In case you miss it, here's an example of what I'm talking about. 4x squared y plus 3xy squared. Tell your neighbor why we cannot combine that one anymore. Yeah, the variables might be the same, but they don't have the exact same exponents. All right. Go. Example 1Q. Copy and go. There it goes. So the first thing is to set it in standard form. Therefore, we got, oh, this is already in standard form. Thank you, Mr. Q. Yeah, you're welcome. All right. This is not in standard form? Yeah, that's why I said the first one is in standard form. Next one, I got plus negative 2a, oh my bad, 2b to the 4th minus 2ab squared plus 9a squared minus 4. I don't use this one anymore. All right, now I can combine. What is 9b plus 2b? That's 11b to the 4th. All right. What is 5a squared b? And there is no other, so I just write plus 5a squared b. They're like, what? Yeah, some of you ran a stop sign, and here this one is different than that. So I just write negative 2ab squared. Next, negative 3a squared and positive 9a squared, that's positive 6a squared. And lastly, negative 7. Hands, have you got that? Hey, that's true. Did everybody see that? Okay, good. All right. How are we doing with addition? All right, subtraction. Copy that. Example 1, super Q. I told you guys today was going to go fast. We don't have a lot of time to be distracted. Just to reiterate. Copy that. All right. Help me out, Ramon. First one. Thank you. Minus, parentheses. Leo, the second one. That is correct. Now that we have it in standard form, what do we notice now? It's a what? Subtraction. What's the invisible coefficient here? 1. That means we're going to distribute to each of the terms right next to it. Bless you. We end up with positive 2a squared b, positive 7a squared, minus 2b plus 1. Now, do I need to bring the parentheses down? No, I already multiplied it in. Therefore, at this point, we just combine. Here it goes. 5a squared b plus 2a squared b, that's 7a squared b. Negative 3a squared, positive 7a squared, that's positive 4a squared. 9b minus 2b, that's positive 7b. And lastly, 5 plus 1, that is 6. Hands, if you got that? Yeah, let's go. Show me if you're going to come to R with addition and subtraction. Classification? So-so? Okay. All right. Shall we? Crank it up a notch. Here goes challenge 1. Write down example 1, super duper Q. Make sure you write small. Here it goes. Parentheses, x squared plus 5x plus 1, close parentheses, minus, parentheses, 2x minus 3, close parentheses, minus, open parentheses, 3x squared plus 5, close parentheses, plus, open parentheses, 7x. That's it? Okay, plus 2. Copy that and go. See how you do. And by the way, I give them to you in standard form, each one of them. Let's go. Let's see. You should have distributed into both terms. This is negative 2x plus 3. Distribute into both terms. This is negative 3x squared minus 5. This one stays the same, so I don't use these anymore. I use everything else. Here we go. X squared, negative 3x squared. That leaves us with negative x squared. Oh, negative 2x squared. Yeah. Next, 5x minus 2x plus 7x. That gives us plus 10x. And lastly, 1 plus 3 minus 5 plus 2. That gives us plus 1. Hands, have you got that? All right. All right, let's move on. Look at this one. Don't copy this. Pay attention. It says, a rectangle has a width of x feet and a length of negative x squared plus 2x cubed plus 1. So what are they talking about? They're talking about a rectangle. So when you get to some of these that you need to apply addition and subtraction, you just draw your whatever they're talking about and label stuff. The width is x. The length is negative x squared plus 2x cubed plus 1. It says find the perimeter. How do we find the perimeter of any figure? Add all the sides. How many sides do we have? 4. Side plus side plus side plus side. So that means we need to label the other side. What is this one? Negative x squared plus 2x cubed plus 1. How about this one? X. We substitute, combine like terms, and simplify. Fairly simple? Yeah. Yes. These are S for sides. Side plus side plus side plus side. Substitute that in here, and there, and here, and there. Combine them. You end up with something, something. And at the end, look what it says. Find the perimeter, and then from there, when the width is 3 feet. So instead of x, what am I going to substitute? 3. All right? Good. Crank it up a notch. Copy these. Example 2. Multiply the polynomials. Now, some of you, I know your noodle's already going ahead of us, which is fine, but I'm using these to get started with explaining certain things that I need to make sure everybody understands before we get into the more complex ones. So multiply polynomials. A, we have 6y cubed and 3y to the 5th. And for B, we have 3mn squared times 9m squared n. Okay? So before I get started doing that, let me just explain one thing. If I gave you the exponential expression that looked like this, a to the 23rd power, the letter a, or the variable a, this is what we know as base. This is known as an exponent. Why am I explaining this? Because I'm about to get into some rules of exponents, and you guys need to know those terms. Once again, a is the base, 23 is the exponent. We got it? All right, good. Good thing you're paying attention. Here it goes. I'm going to do a. According to what we know about multiplying expressions, we multiply numbers times numbers, variables times variables. Okay? But the variables have to be the same kind. So here we go. Monomial times a monomial. What is 6 times 3? 18. Is this variable the same as that one? Yes, the base is the same. So I write the base. So what happens with the exponents when we're multiplying? We add. So this is to the 8th power. And that's it. 6 times 3, 18. Y cubed times y to the 5th is y to the 8th. All right. See if you can do part B by yourself. Huh? It's very similar. Just go numbers by numbers, same basis and same basis. All right, here we go. Help me out with this one. Zab. What is 3 times 9? 27. What is m times n squared? M to the 3rd, because this one has an invisible 1, plus 2, that's 3. What is n to the 2nd times n? N to the 3rd. Hands if you got that. Be nice. Yes. All right. Do this one by yourself. Example 2Q, D and E. Copy that and go. All right, let's see. Jaylene, what'd you get for D? X, 18x to the 5th. Hands if you got that. That is correct. Pass someone. Leo. 10 R squared P to the fourth. Hands if you got that. Yeah, we got this, yes? Because there's an invisible one there. All right, let's move on. Copy this one. Example 2 super cubes. 6p cubed times 2p minus q. I'm going to zoom in. And if you notice, now we have a monomial times a binomial. This one has two terms. This is only one term. Now, once again, to get organized, make sure you use your colors so that you keep organized. I'm going to start with red, this times the first term. Then I'm going to switch to blue, this same one, and I'm going to multiply times the second term. So here we go. 6 times 2, 12. P times P, P to the second. Q times, there's no Q here, so I just bring this one down and I write it right there. Next, same one now times the second term. 6 times, what's the invisible number here? -1, so this is -6. P times, there is no P there, so I just bring that one and write it right there. And Q times Q, that's Q to the second. Yes. The what? You mean in the same, okay, in a, look up guys, good question, they said, Mr. Q, doesn't this one flip around, put the Q squared and then P at the end? That works in standard form when it's a polynomial, a big polynomial. But since this is a monomial, it's only one term, it stays in alphabetical order. Okay? Now, do we combine more? Tell your neighbor why not. Totally different exponents. This one has squared, this one does not. This one has squared, this one has 1 and this is a squared, so it stays like that. All right, copy this one. 5r squared s squared times r minus 3s. Copy that and multiply it. I'll give you some time. Go. All right. So, this times the first term, that gives us 5r squared times r, that's r to the third, s squared, this one does not have an s, so it just stays there. Next, this same one times the second term, 5 times -3, -15, r squared, there's no r squared there, so s squared times s, that's s to the third, and I'm done. Hands if you got that. All right. Now, another way that I showed you guys how to multiply was the area model. Here goes the area model really quick, just in passing. Here's a rectangle. Well, there it is. Rectangle. I'm going to write 5r squared s squared. And on top, we're going to have r and -3s. So if you notice now, I have two little areas. I'm going to find first this area, which is the same thing. This times that. So 5, there's no number there. R squared times r, that's r cubed. And since it doesn't have an s, I just bring it over, s squared. Let me do the second area. This one times this. Is there a number here? Yes, -3 and positive 5, that's -15. There it is. Then r squared, this one does not have any. I just bring it over, r squared. S squared times s, that's s to the third. Did I get the same thing as this? Yes. Just a different way of presenting it. Now, some of us are going to like this because it flows really well and it separates the binomial from the monomial. And once we get into the funner ones in a little bit, you're going to find out that we need more organization for some of us. Right? Carlo. All right. How we doing? Show me your fingers how comfortable you are with these. 5 4s, 5 4s. Okay. Here goes another one. Yes, it is. Copy that one. Example. Shazam Q. 1/2 x squared y times 6xy plus 8x squared y squared. All right, let's do this one together. No? Be nice. Distribute. What is half of 6? 3. X squared times x, x cubed. Y times y, y squared. Next, what is half of 8? Positive 4. X squared times x squared, x to the 4th. Y times y squared, y cubed. Hands if you got that. Okay, good. Move on. Example 2, Star Wars cube. Bam. We've been doing these on the warm-ups, right? Okay. Yeah. Every day I give you what it says. Find the sum, difference, and product. All right. So a times a squared. A times -2, -2a. 4 times a, positive 4a. 4 times -2, -8. A squared, combine like terms, plus 2a minus 8. And how are we doing? Good. And the last one. Y'all ready? Okay. Copy that one. Oh, we'll get to thank you. Thank you. -3x minus 7x squared plus 6 times -2 plus 4x plus 5x squared. All right. Step 1, what do we do? Ethan, in standard form, so we write -7x squared minus 3x plus 6. How about this one, everyone? 5x squared plus 4x minus 2. For this one, you do need your colors. Here we go. -7x squared times all of these 3 terms. So, -35x to the 4th, -28x cubed, positive 14x squared. Hold on. Let me just show you really quick. This one, again, times all 3 terms. And the last one times all 3 terms. And then you combine. All right? Once again, home plate is on pages 277, 291. Have a good one, guys. See you guys. Come always. Bye. Bye.